Um, yes, we are in the final question of IgweMatics challenge set 3. Um, we have x power 5 plus x power 4 plus x power 3 plus x power 2 plus x is equal to negative 1. Um, Obviously, the first solution that I'm very sure everybody got that from me looking at the question. Okay, I saw x equals minus 1. I saw negative 1 here. They just put x equals minus 1. This will give them minus 1. This will give them plus 1. This will now cancel out. This will give them minus 1. This will give them plus 1. This will give them minus 1. This cancel out, leaving them with minus 1 is equal to minus 1. I'm very sure that's where they got the answer from. But they are forgetting, they all forgot that um, this polynomial have a degree of 5. So there must be 5 solutions. That is, there must be 5 solutions for x, 5 distinct. It must not be distinct, they could be the same, but there must be 5 solutions for x. All of them are just saying x equals to minus 1. So I said, let me find out which other value of x is possible, which other value of x are there. So the first thing I would want to see is, okay, I've noticed that this summation here is the same as x to the power of n, from n equals to 1 to n equals to 5. But this doesn't really take me anywhere, so I would erase that. The next thing I want to try is moving this negative 1 to the left hand side. If I move negative 1 to the left hand side, I will get x to the power of 5 plus x to the power of 4 plus x to the power of 3 plus x to the power of 2 plus x plus 1 is equal to 0. Now looking at this, if we multiply all through by x minus 1, we will get x times x, that's x to the power of 6, x times x plus 4, that is x to the power of 5, plus x to the power of 4, plus x to the power of 3, plus x to the power of 2, x times 1, that is plus x, minus 1 times minus 5, that is minus x to the power of 5, yes, minus, yes, we're going somewhere, minus x to the power of 3, minus x to the power of 2, minus x minus 1, all is equal to 0, because 0 times x minus 1 will still be 0. So all this will cancel out, leaving us with x to the power of 6 minus 1 divided by x minus 1 is equal to 0. That means x cannot be 1, because if x is 1, this would make us divide by 0. So x cannot be 1. So we have to look for the solutions of x to the power of 6 minus 1 is equal to 0. That means x to the power of 6 is equal to 1. So we have to look for the solution of x to the power of 6 is equals to 1 when x is not 1. This is confusing, so I want to take a different approach. Well, I just realized that if I follow that approach, we'll still wind up, because what I just finished showing there was that x to the power of 6 is equal to 1, where x is not equal to 1. So people might look at this and just be like, I'm just moving in circles. So instead of following that approach, let's follow a new approach. Okay, this new approach bar is a little bit different, but it still solves the question, and we're still going to move this guy to the left hand side. We're going to do something different. So we have x to the power of 5 plus x to the power of 4 plus x to the power of 3 plus x to the power of 2 plus x plus 1 is equal to 0. Now we know from the start, remember I said that x is equal to negative 1, because negative 1 works in the question. So if x equals to negative 1, that means x plus 1 is equal to 0. If x plus 1 is equal to 0, that means x plus 1 is a factor of this polynomial. So we can divide this polynomial by x plus 1. So one of our solutions, let's put our solutions for x over here. Let's put our solutions for x over here. Solution of x1 is equal to negative 1. So if x is equal to negative 1, we can divide this polynomial by x plus 1. If we are dividing the polynomial by x plus 1, we're going to do long division. Okay, if you want me to show you how to do long division, you can tell me in the comment and I'll make a different video for that. But for this, I'll just go through all the process. That's x power of 5 divided by x, that's x to the power of 4. X to the power of 4 times all this, that's x to the power of 5 plus x to the power of 4. If you subtract that, this will cancel this and this will cancel this, leaving us with x to the power of 3 plus x to the power of 2 plus x plus 1. X power of 3 divided by x will leave us with x squared. X squared times x, that will leave us with, that will be x cubed plus x squared. If we subtract, this will cancel this and this will cancel this, leaving us with x plus 1. X divided by x, that will leave us, that will be 1, and 1 times x, that is x plus 1. If we subtract, this would be 0 and 0. So basically, yes, this method is better than the first approach. This approach is going to be better than the first approach. So basically, what I'm actually showing here is that we first of all moved -1 to the other hand, the left hand side, giving us x power of 4 plus x power of blah 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 is equal to 0. Now we factored out x plus 1. Since x plus 1, we already know that x plus 1 is a factor of the first polynomial because x is equal to -1. So if we move -1 to the other side, we know that x plus 1 is going to be a factor of this big guy over here. So you now we just finished doing long division, dividing this big guy divided by x plus 1, giving us this smaller guy here. That means x plus 1 times all this is going to give us x power of 4 plus x power of 4 plus x power of 3 all the way to 1. And if we know that we already, if this is going to give us if the factor that x is equal to -1, so we've already used that. Let's now use this to get our remaining factors of our remaining values of x. So if we're solving this, instead of solving a polynomial to the degree of 4, we could just let y equal to x squared. If we let y equal to x squared, then this would, that means y squared is equal to x to the power of 4. So this is y squared plus y plus 1 is equal to 0. But let's solve. So this is y equals to 2ay. Divide both sides by y, that means 1 is equal to 2a. 1 over 2 is equal to a, that means 1 over 4 is equal to a squared. So we add 1 over 4 to both sides. This will give us y squared plus y plus 1 over 4 is equal to -1 plus 1 over 4. This is the same as -4 over 4 plus 1 over 4. And that is equal to -3 over 4. For the left hand side, we can now group this as y plus 1 over 2 all squared. Now the reason why we can group this as y plus 1 over 2 all squared because y times y will give us y squared, y times 1 over 2 will give us 1 over 2y, and 1 over 2y times y will give us plus 1 over 2y, which will both sum up to give us y, and 1 over 2 times 1 over 2 will give us 1 over 4. So we know that y plus 1 over 2 all squared will be equal to -3 over 4. Now, I'm not going to explain to you people what imaginary number is because I believe that you already have knowledge of imaginary number. We now know that y plus 1 over 2 all squared is equal to -3 over 4. So that will be y plus 1 over 2 all squared is equal to -3 over 4. That means y plus 1 over 2 equal to the square root of -3 over 4. That means y is equal to -1 over 2 plus minus the square root of -3 over 4. Therefore, this implies that y is equal to -1 over 2 plus minus the square root of negative 3 over 2, because square root of 4 is 2. So we can add all these together as divided by 2 negative 1 plus minus I root 3. Yes. Therefore, our two solutions for y is equal to negative 1 plus minus I root 3 over 2. So y is equal to negative 1 plus I root 3. Let me write that down here. Therefore, y1 is equal to negative 1 plus I root 3 divided by 2, and y2 is equal to negative 1 minus I root 3 divided by 2. But don't forget that x is that we're not looking for y. Don't forget that we're not looking for y. Instead, we're looking for x. And remember that we said y is equal to x squared. So x is going to equal to the square root of y. Remember that y equals x squared, so x is going to equal to square root of y. So our x, we already have our x1 here. Let me erase this unnecessary part. X equals square root of y, we have our y1 and y2. So x could equal to plus minus the square root of y1, which is negative 1 plus I root 3 divided by 2. And our x could also equal to plus minus the square root of negative 1 minus I root 3 divided by 2. So that is basically what gives us our four equations, because now we can see that our x1 is equal to negative 1. Now we can say our x1 is equal to negative 1. Our x2 is equal to plus the square root of negative 1 plus I root 3 divided by 2. Our x3 is equal to minus the square root of negative 1 plus I root 3 divided by 2. And our x4 is equal to plus the square root of negative 1 minus I root 3 divided by 2. And our x5 is equal to minus the square root of negative 1 minus I root 3 divided by 2. So basically, these are our 5 solutions for x. These are the 5 solutions for x that work in the question. So x could be negative 1, or this, or this, or this. But all these can be simplified. By just saying that x from 2, 3, 4, and 5 is equal to plus minus the square root of negative 1 plus minus I root 3 divided by 2. So this plus minus will give us 2 solutions, and those 2 solutions, this other plus minus will give us 2 times 2 solutions, which will be 4 solutions. So that is basically what will give us our solution for 2, 3, 4, 5. So that's basically like the 4 solutions for, all this can be simplified into this. So that is the solution for x power 5 plus x power 4 plus x power 3 plus x power 2 plus x is equal to negative 1. I don't know if you understand. I don't know if you understood what I just. I don't know if you understood what I just finished saying, but I pray you understood what I just finished saying there. Yeah. Follow IgweMatics. Yeah.